All right, ladies and gentlemen, today we've got classwork 10.7, more applications of exponential decay. This lesson is very, very similar to Monday's, only now instead of exponential growth, we're looking at percentages and exponential decay. So, in the previous sections, we've been examining quantities that grow by percentage. Today's lesson, we are going to apply your understanding of exponential functions to quantities that are decreasing by percentage, also known as decay. So number one, the whole number one, the whole front side, I'm going to do with you, and then you'll start Socrative when you flip it over, and you start looking at the back side. So this whole front side I'll be doing with you. Number one, at the peak of the Beanie Baby fad, one sales representative sold 12,000 of the animals in 1 month. Each month after that, the rep sold about 20% fewer Beanie Babies. So, question A, how can you determine the number of Beanie Babies sold in the first month? Be prepared to share your ideas with the class and record the value in the table. So just like on Monday, we want to figure out what is 12% of that number. I'm sorry, what is 20% of that number? So we're going to take 12,000. We're going to multiply that by let's do 20%. So 12,000 times 20%. And the same way we turned the percent into a decimal last time, we're going to do that same thing. So this decimal right here is going to move 2 spots. So it's actually going to turn into 12,000 times 0.20. And when we do that into our calculators, so 12,000 times 0.20, we get 2,400. And now instead of adding that number to our original, we're going to subtract that number from our original. And that's because we're selling less Beanie Babies. So I'm going to take 12,000 and subtract that from 2,400, and I get an answer of 9,600. Once again, let's see if decimals make sense. Does it make sense that we're going to sell a half of a Beanie Baby or a quarter of a Beanie Baby? No, it does not. So make sure that if there are any decimals in this column, we round it to the nearest whole number. All right, how can we determine the number of Beanie Babies sold in the second month? Well, we're going to do the same thing. We're going to take our amount of Beanie Babies, which is 9,600. I'm going to multiply it by that 20%. But remember, we want to do it as a decimal. So we move that decimal 2 spots, and we're going to multiply it by 0.20. So I can put into my calculator 9,600 times 0.20, and I get 1,920. And then I want to take that number and subtract it from the original. So 9,600 minus 1,920. And I get 7,680 Beanie Babies after the second month. 7,680 Beanie Babies after that second month. All right, C, use the process developed in parts A and B to complete the table. So I'm going to keep doing that. So go ahead and pause your video and then complete the table and find how many Beanie Babies were left or were sold in month 3 and in month 4. All right, so that's what our table should look like. We've got 6,144 after the third month, and we sold 4,915 after the fourth month. Be careful, there was a decimal for that one, but once again, we want to round to the nearest Beanie Baby. So decimals don't make sense in this case. All right, question D. Do you think this is a linear or an exponential relationship? Explain your answer. So in order to figure that out, we've got to look at our pattern. So how do we go from 12,000 to 9,600? Once again, if we think it's linear, then we should be able to subtract by the same amount every time. So on my calculator, I should be able to go 12,000 minus 9,600. And that would be subtracting 2,400. Okay. If this is the case, then I should be able to take 9,600 minus 2,400 and get the next number. That is not the next number, though. My next number is 7,680. So this must not be linear, and we've got to find a pattern that works. So in order to do this, we're going to divide the bottom number by the top number. So we want to put into our calculators 9,600 divided by 12,000. And we get an answer of 0.8. So that means we are multiplying by 0.8 each time. Okay. And let's just make sure that works. So let's take 9,600 times 0.8. And yes, we do get 7,680. So we're going to take each of these numbers and 8. Perfect. So to answer question D, is this linear or exponential? It's exponential. Because we are multiplying by the same growth ratio each time. By the same. All right, so there's my answer. It's exponential because we are multiplying by the same growth ratio each time. Feel free to pause the video so that you can write that answer down. Next question is question E. Write an equation that will determine the number of Beanie Babies sold if we know the number of months. All right, so we're going to start out our exponential equation with y equals. We are still going to start out with the original number. So at month 0, we had 12,000 Beanie Babies sold. So 12,000 times my growth ratio. So once again, this isn't changing. 0.8 to the x power. Use your equation to determine the number of Beanie Babies sold in the 12th month. So in order to do that, we're just going to type it into our calculator. 12,000 parenthesis 0.8 end parenthesis to the 12th power, and then press enter, and we'll have 824.6. I'm going to round that number up to 825, though, since we are talking about Beanie Babies. So we should have 825 Beanie Babies left, or Beanie Babies sold. All right, and our last question, question G. In which month did the representative first sell fewer than 500 animals? So we want our equation of 12,000 times 0.8 to the x, and we want that number to be less than or equal to 500. So 2 ways we can do this, we talked about it last time, is we can just guess and check. So you can start putting numbers in here and to see when is the first time we sell fewer than 500. Other than that, we can try doing it as a table on our calculator. So I'm going to go to my y equals, and I'm going to put in the equation. So my equation is 12,000 times 0.8, so parenthesis 0.8, and that's to the x power. All right, and if you have any troubles with that, just please raise your hand, let me know, and I can help you out with typing that equation in there. So after we've typed in the equation, we can go to the table. So I hit second graph, or the blue button, and then the word graph, and I can see my table here. The last numbers after 6 months, we're still at 3,000, so I want that number to be less than 500, so I'm going to scroll down until I get a number less than 500. Okay, right there. So at 14 months, we still sold 500, so we're okay. But as soon as we cross over